To help us understand the concept of critical path analysis better, we're going to be treating this illustration. For the diagram in the next slide, we will have to identify the various paths in the network diagram, and then we'll have to calculate the float of all the activities and then find out which of the paths is the critical path. So we can see this diagram, and of course this diagram sometimes in the PAP exam can come in just a table. So you may be given a table and asked to draw a network diagram from there and then analyze the network diagram. So let's see how to solve a critical path analysis problem. To solve a critical path analysis problem, the first thing to do is to identify the various paths. So let's give it a shot. We have paths A, B, C, G, and this gives us a total duration of 4 plus 3 plus 1 plus 2. You add the individual durations, that's the duration of the activities that make up paths A, B, C, G. These are called paths. So that gives us 4 plus 3, 7, 7 plus 1, 8, 8 plus 2, 10. And then which other path do we have? We have paths A, B, F, G. A, B, F, and G. This gives us a total duration of 4 plus 3, 7, 7 plus 6, 13, and then 13 plus 2, 15. And so which other path? We have paths D, E, F, G. D, E, F, G. This gives us a duration of 5 plus 4, 9, 9 plus 6, 15, 15 plus 2, 17. And the last but not the least is path D, H, I. This gives us a total duration of 5 plus 4, 9, 9 plus 2, 11. And so from the various paths that we have, we can see that the path with the longest duration is path D, E, F, G. And by definition, the critical path is the path with the longest duration. And so we can identify that this is the critical path, D, E, F, G. So you can put a line there, D, E, F, G. That's the critical path. And so now we start the analysis. And so the analysis, you will observe that we have, you have day 1, and then when you start the project on day 1, you finish it on the, you use a formula called early finish is equals to early start plus duration minus 1. And so that's 1 plus 5 will give us, that's 5, will give us 6 minus 1, that's 5. And then we have, this will now start on day 6, and if this is the 6, this will be 9, and if this is 9, this will give us, we assume this will start the next day, because except otherwise stated, the relationship you see here is relationship called finish to start. And so this is 10, this will be 15, and so this is 15, this will be 16, and of course you have 17. And because DEFG is the critical path, on the critical path, the float of all the activities is giving us 0. So you can fill in all the float as 0. This is 0. I'm writing. Wow. Okay, so just fill in the various duration, the late durations, the late dates now. So that's 1, and then you have 5, and then you have 6, and then you have 9, and then you have 10, and then you have 15, you have 16, you have 17. Because that is the critical path. The float of every activity on the critical path is 0. And so we can move on to the other part. The next part to look at is part A, B, F, G. And so we start with day 1, and if this is day 1, this will be 1 plus 4, 5 minus 1, and that is 4. And if this is 4, this will give us 5. And so going ahead, this will be 5 plus 3, 8, 8 minus 1 will give us 7. And this is 7, this will give us 8, this is 8, 8 plus 1, 9 minus 1, 8. And so coming backward, this will now give us, if this is, because the late start of activity G is 16, then we get this as 15. Now this is so because C and G are related by finish to start, so G is a successor to C. And so going backward, we use a formula called late start is equals to late finish minus duration plus 1. So you observe that during your forward pass, that when going from start to finish, the unknown is usually the early finish, while going on your backward pass, the unknown is usually the late start. So if this is if the late finish of activity C is 15, then it means that using the formula, this will also give us 15. And of course, the float is 7. That's the float is equals to late start minus early start, or late finish minus early finish. And so if this is 15, and then when you have a scenario where there's a divergence going on your forward pass, there's a divergence between activities B, C, and F, meaning that C and F can only start after B is finished. In this scenario, you go for the successor with the lower date, or with the earliest date, and that is activity F. So since activity F starts, the late start for activity F is 10, this will give us 9. So if this is 9 minus 3, that is 6 plus 1, 7. So the float is 2. And if this is if the late start of activity B is 7, this will give us 6. If this is 6 minus 4, 2 plus 1, 3. So the float is 2. Right? I hope you get it up to this point. And then we move on to the last part, which is part DHI. Part DHI, successor to H is D. So if if the early finish of activity D is 5, it means the early start of activity H will be 6. So we go on 6 plus 4, 10 minus 1, that will be 9. And then this is 9. The early start of activity I will be 10. And if this is 10, 10 plus 2, 12 minus 1, that's 11. And so going backward, now the same concept you use when trying to identify the early start of activity A. Now the activities on the starting line usually have the same early start date, while the activities on the finishing line usually have the same late finish date. So that means that the late finish of activity I will give us 17. So if this is 17, using the formula, this will be 17 minus 2, 15 plus 1, 16. And so the float is 6. And so if this is, let me write 16 well. And so let's go on. If the late start is 16, and then the late finish of activity H will be, so this is 15. And so if this is 15, this will, the late start will be 15 minus 4, that is 11 plus 1, and that is 12. And so the float is 6. So by now I'm sure that you've been able to learn how to perform forward pass and the backward pass. And so from these we've been able to get all the early dates and the late dates of all the activities on this particular network diagram. And we can see that the importance of the critical part is that the activities on the critical part are those activities that must start as and when planned, finish as and when